Today we're going to talk about transforming formulas. Okay, can somebody guess what we mean by transforming formulas here? What do you think we mean by this? Yes?
Maybe you take a formula and change it to an equation.
Formula is an equation, but so almost, but we're going to rewrite equations, well, the formula into sort of different way. How many people know what a transformer is? You know, the movie Transformer. Yeah. It changes shape, right? But it's the same thing, isn't it? So, for example, that's the idea, guys. Here, if I have this formula, D is equal to RT. How many people have heard of this formula before? Very good. Royce, what does it represent?
Rate times time equals distance.
That's distance equal to rate times time is exactly right. No, this formula is really useful if you know the rate and time. All you have to do is multiply rate and time and you get the distance. Okay. But is there a way to transform this formula so that
you can find time.
Yeah, so yeah, exactly. By the way we say this is D is written in terms of R and T. Okay, so write that down. You see how I have D is equal to RT? Look at D is equal to, what did they write D? Using which letters? R and T. Which, these are the variables that are using to represent D. Does that make sense? So when you have D is equal to RT, you could say D is written in terms of R and T. In terms of means they're using R and T to represent D. That's all it means, okay? So it may sound sort of hard, but it's not really. Okay, so write that down. I'll wait. So again, when they say in terms of, they just mean D is written using, right? Rate and time. Is that okay? Now, as we were saying, we could transform this formula. What if you want to solve for example, R? What if I want to write R in terms of D and T? So, in other words, if I know D and if I want to write R by itself, that's basically what we're doing. One person sees how we could write this. Is there a way to solve for R? In other words, is there a way to write R in terms of D and T? Michael?
Is it D divided by T?
Yeah, divide both sides by? Divide both sides by? If I want R by itself, I need to divide both sides by? T. So, here, don't you get simply R is equal to D over T? So it's basically saying, right, I can solve for R by just, you know, it's just same, very similar to solving for X or something like that. Think about R as like X, right? And D and T as some number, right? If I have like 3 equals to X times 4, you divide both sides by 4, something like that, right? Same idea. And when do you think this transformed equation, you see how it got transformed? We had D is equal to RT. Now we have R equals to D over T. When do you think this transformed equation is useful? If you know which two values? Yeah. Distance and time. If you know the distance and time, to get the rate, all you have to do is distance divided by time. Then you get the rate right away. Does that make sense? Do you see why we sometimes want to transform these equations? Right? The first one, if you knew the rate and time, you get distance right away. That's nice, right? But what if I know distance and time? Right? Then you could just do distance divided by time. Do you see what we're trying to do? So we solve for D, we solve for R. What's left? What can we solve for now? Anybody want to guess? We solve for D. Well, we didn't solve for D. We had D equals RT. So we had D by itself. We had the R by itself. Could we get something else by itself? Dana? We could get T by itself. So from the first equation, could we solve for T? In other words, can we solve for T in terms of the other variables T and R? Can you guys do this? Go ahead, everybody try. I'll wait. So if I had this equation, how would you transform this so that you get T by itself? Go ahead, I'll wait. Alright, so all you have to do is what? How about Mimi? Yeah, you could just divide both sides by R and don't you get T by itself? Like think T as like X. That's what you're solving for, right? So divide both sides by R. Because you know R and T are multiplying, right? So divide both sides by R. And of course, what do we get when we do that? Yeah. Yeah, t equals d over r. We get d over r equals t. You know, you can rewrite that as t equals to d over r. Because normally we write that, you know, the number, I mean, variable that we're solving for on the left side. Easy. Question? Any question? Is this easy? All right. Can I move on?
Yeah.
Okay. Take a look at this example 1. It says example 1a. We have d is equal to m over v. And it says solve for m in terms of course, d and v. Those are the other variables. By the way, does anybody recognize this formula? Yes, sir. No. Yeah. Aiden? Yeah, this density equals to mass over volume. By the way, on tonight's homework, they're going to give you a bunch of formulas. Do you have to know what they really represent and so forth? No, that's not important. But you have to solve for the variable that they're asking you to solve for, right? So in this case, can you solve for m?
Yeah.
Go ahead, everybody try. Solve for m in terms of d and v, okay? All right, Christina, what do I do?
You multiply both sides by v.
Yeah, you multiply both sides by v and you're done, aren't you?
Yeah.
Right? Because imagine that m is your x, right? It's like x over some number. Don't you multiply both sides by the denominator? And how many people got m equals to dv? Easy enough? Oh, some of you didn't. But do you see your mistake if you didn't? Okay, do you see how you solve for like that variable? It's sort of saying solving for x. All right, so far these been sort of pretty straightforward. And now let me give you something kind of interesting. This is where people make a lot of mistakes. Okay, so let me show you. Using the same formula, watch this. Now I want you to solve for v. Using the same formula, we had d is equal to m over v. Can you solve for v? Okay, I'll wait. And of course, you could talk to your neighbors, your group, you know, to help and try to figure this out together. Go ahead if you're stuck. Okay, everybody try. Hey guys, this problem is one of, like I said before, I see a lot of people make silly mistakes on this. Did anybody get v is equal to d over m? Because you divide both sides by m, both sides. Raise your hand. If you got v is equal to d over m. Okay, that's how you get it wrong. Let me show you why. Does anybody need to see why that'll be wrong? Camilla. Yeah, hold on to that. You're right. We could do something like that. But why would this be wrong? Can we just divide both sides by m? Don't you just get d over m equals to v? No. What do you get? Instead of d over m, you don't get equals to v if you divide both sides by m. You get? Yeah. Yeah, what I'm saying is no, you don't multiply, then the m doesn't go away. You see how the v is on the denominator? You get this, 1 over v. Look what happens. If you divide both sides by m, that's the same thing as multiplying by 1 over m, right? So does the right side become v or does it become 1 over v? 1 over v. Are we solving for 1 over v or v? V. So if you did this, right, and if you thought that v is equal to m over d over m, that would be wrong. So then how do we do this? Anybody? 2 people see it? 3? 4? Patty, what did you do?
Okay, so first I multiplied by v.
Uh-huh.
And then I divided d, and so I got v equals m over g.
Exactly right. Did you hear what she said first? Okay, let me give you a little trick. Do you see how the variable is on the denominator? Yeah? You see the variable that we want to solve for is on the denominator? Let me give you a little hint here. If the variable is on the denominator that you want to solve for, you need to bring it up to the numerator. And how do we do that? Because it turns out, if the variable is on the denominator, it's very hard to solve for it. Okay, so you need to bring it up to the numerator. How do you do it? Patty just told us. How do you bring the v over to the numerator? Yeah. You multiply both sides by that variable. Look what happens if I do that. Here we had this. When you multiply both sides by v, right? What happens to v? On the right side, it cancels out. That's okay. What happens on the left side? V is on the now. Hello? Where did the v go? On the right side, the v's cancel out, right? But look, v is on the left side. And isn't that on the numerator? You can think of it as numerator, right? The whole thing over 1. You see how it just becomes simply this. Vd is equal to m. And look at where v is now. Is v on the denominator? No, not anymore. Now we know how to solve for v. all you have to do is what, class? Divide both sides by d. So first of all, let me finish the. Okay, so I get v is equal to m over d. Any question? Do you see how if your variable, so I wrote this down for you. If the variable you want to solve for is on the denominator, guess what you have to do? Bring it up to the numerator by multiplying both sides by that variable. Do you see the trick? Okay, you need to know this. So it says if the variable you want to solve for is on the denominator, bring it up to the numerator on the other side, okay, of the equation by multiplying the variable both sides. So that's why we multiply both sides by v. Does that make sense? Okay. So look, v was on the denominator. Like I said, it's very hard to solve for that variable if it's on the denominator. You have to bring it up to the numerator. How do you do that? Multiply both sides by that variable, v. Okay. Now, v is on the left side, right? Because right side it cancels out, right? And of course, you just have to solve for v. Any questions? Yes? If you know what I mean, you don't have to, but it's up to you if that helps you. I just wrote it out. Any other question? Do you see what I did? Can you do something like this for your homework tonight then?
Yeah.
So please make sure if the variable you want is on the denominator, multiply both sides by that, okay? You don't want it on the denominator. It's hard to solve for it if you do that. Okay? Do I need more time? Okay, I'll wait. Alright, so do you see why if you divide both sides by m, let me show you again, right? You don't get v on the right side. What do you get if you just divide both sides by m? You get 1 over v. That's not what we want, okay? Please be careful. Does that make sense? Alright, let's move on to then next example, okay? Here's example 2. It says solve for h. S is equal to 2 pi r h plus 2 pi r squared. Again, it is not important to recognize that formula, but does anybody know what it is? This formula represents what? Raise your hand. 2, 3. Matthew? Yeah, sure. Okay, what do you think?
The area of a cylinder.
Area of a cylinder. What kind of area of a cylinder?
Surface area.
Surface area, you're right. It's the surface area of a cylinder. Because remember you get two circles, right? That's why you get 2 pi r squared, and then this is the rectangle if you open it up. Anyway, so that's not important, but let's solve for h. So before I do this though, right? Before you do this, let me ask you this question. Do you know how to solve this? 4 equals to 7x plus 5.
Yeah. No. Simple.
No?
Yeah.
Okay, I hope you do. Okay. So if I have 4 equals to 7 plus 5, okay, let's just sort of hide this for a second. You know how to solve this equation, don't you? What would you do, Carolyn? If I want to solve for x, you will first do what?
Subtract 4 from each side.
You can't do that.
You want to get x by itself, don't you?
Oh.
So what would you do?
5.
Subtract 5 from both sides, then what? Then you get 7x equals -1, right? Then what do you do? Divide by 7. Right? Do you see? You all know how to do this, right? I claim to you that if you know how to do something like this, you could solve for h on this one. Because think about h as like a variable that you're solving for, like x, and treat all the other numbers as some number. So for example, treat s, think of s as like 4, 2 pi r as like 7, and then 2 pi r squared as 5. Well, what would you do to solve for h? First, what would your first step be? Okay, I want you to then try yourself. Go ahead. I claim to you that if you know how to solve for 4 equals to 7x plus 5, this equation is very similar. Okay, do this as if you're solving for x. I'll wait for you. Go ahead, everybody try. Who thinks they can help us how to solve for h? And let me just hide this for a second. All right, how about Carly? What should I do first?
Subtract 2 pi r squared from both sides.
That's right. I want to subtract this 2 pi r squared from both sides. Because don't I want to get the term with h by itself?
Yeah.
And you could treat this as some number, right? If you have a number, right, plus some term with the variable, you just want to get rid of that to the other side so that you get a term with that variable by itself. So you're going to subtract 2 pi r squared both sides, and you just get s minus 2 pi r squared is equal to 2 pi r h. Now, all you have to do is what? Raise your hand if all you have to do is what? Actually, don't raise your hand. I'm going to call somebody random. What do you think I should do here, Bella?
You divide 2 pi r.
Exactly. You need to divide both sides by 2 pi r. Then you will get h by itself. Isn't that right? So, because think about this, Chuck. Remember how we had 4 equals to 7x plus 5. We subtracted 5 from both sides. That's the same idea as what we did here. And if you have 7x equals negative 1, how do you get x by itself? Divide both sides by 7. Instead of 7, what do I have on the left side? 2 pi r. So guess what? I'm going to divide both sides by 2 pi r. Do you see why I did this simple example here? Do you see why they're similar? Right? Okay, so what's the answer? Raise your hand. Okay, no, raise your hand. Actually, how about Chris? Tell me what to write. What's my answer then?
H equals S minus 2 pi r squared over 2 pi r.
Exactly right. Oops, let me move this down a little bit. Okay, so did you get this? S minus 2 pi r squared over 2 pi r equals to h? Right, can we just cancel things out? Look, I got 2 pi r down here. I have 2 pi r squared. Carolyn, let me ask you this. If I have 4 minus 7 over 7, can you cancel out these 7s together? So you think the answer will be 4 minus 1 over 1, which is wrong. You can't cancel those out. What does it mean when you cancel out from the top and bottom? You are dividing the whole numerator by that number that you're canceling. How many terms do you have in the numerator?
2.
You can't just cancel out 2 pi r with 2 pi r here. The 2 pi r has to be a common factor for both of these terms on the top. So you can't just cancel these out. Just like you cannot cancel these out like this. What's 4 minus 7 over 7? Does that equal to 4 minus 1? No. Right, guys? Does that make sense? You can't cancel this out. When can you cancel this out? If you had what here in the middle? Instead of subtraction, if you had multiplication, then you could cancel out because you could divide top and bottom by 7. Does that make sense? So please be careful. Yeah, this is what you leave it at. Any question? Hold on. Any question? Raise your hand if you got this right. Raise your hand. Raise your hand if you see what you did wrong.
Thank you, Royce.
Go ahead and fix it now. I'll give you time, okay? Some of you asked, could we divide both sides by, in the very beginning, could we divide both sides by h? Would that help you? No. Then you would have 2 terms with h. If you were to divide the original here, if you were to divide this original one by h, right? Then you would have s over h. Of course, the h will cancel out, but you're going to have 2 pi r squared over h. Right? Is that going to be helpful?
No.
No, because not only do you have now h in 2 different terms, h is going to be on the denominator. You don't want to do that. Does that make sense? Any question? Hold on. Hey guys, we're not done. On your homework tomorrow night, it's going to ask you to do something like this. Listen. And there's another part that will say, write the restriction. We're going to talk about that on Monday. Okay? So you don't have to write the restrictions for now. Is that okay? Just on your homework tonight, tomorrow night, just solve for the variable. Is that okay?
Yeah.
All right.